Welcome to this video, which is a review of 3.1, 3.2, and 3.3 for Math O82. So, let's begin with the first problem. The first problem is x squared times x to the 7th power. Here we need to apply the product rule, which asks us to add our exponents. 2 plus 7 is 9, so our final answer is x to the 9th power. Number 2 is also an application of the product rule. However, notice that we are adding a number that is positive to a number that is negative. 4 plus negative 11, or 4 minus 11, is negative 7. So we have z to the negative 7th power. However, notice that our answers must have only positive exponents. Therefore, we have to rewrite this as 1 over z to the 7th power. Let's go to number 3. Here we're going to apply the quotient rule. The quotient rule tells us that when we are dividing, as we are here, we need to subtract our exponents. 18 minus 13 is 5, so therefore our final answer is y to the 5th power. Number 4 is an application of the power rule. So when we have a power raised to a power, we need to multiply those two numbers. 3 times 5 is 15, so our final answer is z to the 15th power. Number 5 is also an application of the power rule. However, we have to make sure that every single thing in the parentheses is being raised to the 3rd power. We start with our constant, which is 5. So 5 to the 3rd power, and then we have x to the 4th, raised to the 3rd power. We have y to the 5th, raised to the 3rd power. So again, the coefficient, 5, as well as all the variables, are getting raised to the 3rd power. 5 to the 3rd power is 125. And then for the rest, we can multiply our exponents. Doing this, our final answer is 125 x to the 12th, y to the 15th power. Next, we have 4x to the negative 3rd. Now looking at this, it might not seem obvious at first what we need to do. There doesn't seem to be any rule that needs to be applied. However, when we remember that we have to rewrite this using only positive exponents, then we can remember that we need to rewrite it as 4 over x to the 3rd power. In number 7, we need to raise everything to the 2nd power. So we have negative 2 quantity to the 2nd power, and then we have m to the negative 4th quantity to the 2nd power. Negative 2 quantity raised to the 2nd power is positive 4, and then over here with the m, we apply the power rule and multiply our exponents. Unfortunately, we're not quite done because we still have a negative exponent. Therefore, we must rewrite this as 4 over m to the 8th power, and that can be our final answer. Number 8 might look very simple and straightforward. After all, you just need to apply the quotient rule. However, it's a little bit tricky because we're supposed to subtract negative 9 from negative 4. So we're going to have negative 4 minus negative 9. Notice that if you're not careful, you might miss some of the signs. Minus a negative becomes plus a positive, and negative 4 plus 9 is 5. Therefore, for this problem, our final answer is x to the 5th power. Let's keep going. Number 9, again, is getting even more difficult and challenging. In fact, we'll probably have to use the quotient, the product, and the power rule all at once. So let's start with some colors. So 4 over 8 can be reduced. Specifically, we can reduce 4 over 8 to 1 over 2. Then we can keep going. So in addition to changing or reducing 4 over 8, we can look at our x's. Okay? So I have x squared divided by x to the negative 3rd. So remember that means that I need to subtract my exponents, and I'm going to write that out. So it's 2 minus negative 3. Okay? Next we have our y values, and if we look at our y values, we have negative 3 on the top, and we have 4 on the bottom. So we have negative 3 minus 4. Lastly, we have a z on the top and a z on the bottom. You could think of that as z to the 1 minus 1 power, or since they're exactly the same, you can cancel them out. Either way, you don't need to write that, but you can if you want to. It's not going to change your answer. And all of this is still being raised to the second power. So let's simplify our exponents. So we still have 1 over 2, and then we have 2 minus negative 3. Minus a negative becomes plus a positive, so we end up with x to the 5th power. Then we have negative 3 minus 4. That gives us negative 7. And again, everything is still being squared. Notice that we don't really need this 1 here. The 1 is kind of extra. If you want to keep it there, you can, but again, it's really not necessary. So we're almost at the last step. The next thing I'm going to do is I'm actually going to raise everything to the second power. So in order to do that, we're going to have x to the 10th, y to the negative 14th, over 2 squared, which is 4. Now we're almost done here. However, notice that we still have a negative exponent, and we can't have negative exponents in our answer. Therefore, we have to rewrite it with the y in the bottom. So our final answer is x to the 10th over 4y to the 14th. And I apologize, I ran out of room, so I went a little bit over. But hopefully you can still read and see the answers. So going back to this problem, if I had left it as z to the 1 minus 1, that would give me z to the 0 power. So you need to remember that anything raised to the 0 power is just 1. So therefore, the answer to number 10 is 1. We can leave it like that. All right, let's look at number 11. So here, I would suggest rearranging the furniture. So we have a 6, a 5, and a 3. So I'm going to rewrite this as 6 times 5 over 3. Okay? So as we keep going, then we will look at our x's. So if I look at my x's, I have an x to the 8th, which I will write here. I have an x to the negative 3rd, which I will write here. And then I have an x to the negative 5th, which I will write down here. Okay? Let's keep going. And so now we can look at our y's. We have a y to the 4th power. We have a y squared. And then downstairs, we just have a single y. Or, if it makes you happy, you can remember that it's actually y to the 1st power. So the first thing I want to simplify is the actual constants. So 6 times 5 is 30. So I will have 30 over 3. Then in the numerator, we have 8 plus 3. So we have x to the 11th. And we'll keep x to the negative 5th in the denominator. We won't change that. Then we have y to the 4th times y squared becomes y to the 6th. And downstairs we have y to the 1st power. Okay. So let's see how we can continue to reduce this. So if you type in your calculator 30 divided by 3, that just gives us 10. Then we have x to the 11 minus negative 5. Be careful with your signs there. And then we have y to the 6 minus 1. Okay, so we're almost done. So we're going to have 10. Remember, minus a negative becomes plus a positive. So we get x to the 16th power, and then 6 minus 1 is 5. So this is our final answer, 10 to the 16th power, 10x to the 16th power, y to the 5th power. Okay, let's keep going. Okay, in number 12, we are asked to rewrite this number that's in standard notation in scientific notation. So to do this, we have to figure out here, our decimal place is starting here, and then we need to move it over 1, 2, 3, 4, 5, 6, 7, 8 places. So we know that we're going to have either 10 to the 8th or 10 to the negative 8th. So we're going to have 4.7 times 10 to the either 8 or negative 8. So how do we remember which one is which? Well, what we do is we go back to this original number and ask ourselves, is this less than 1 or is it greater than 1? Okay, this number is very much smaller than 1. It's smaller than $1. When you have a number that's smaller than 1, then your exponent must be negative. Okay, so that's your final answer. So let's keep going. So now we have 2.67 times 10 to the 5th power. So we need to move this decimal place over 1, 2, 3, 4, 5 units. And in those empty spaces, I need to fill in zeros here. So my final answer is 267,000. So if you're wondering, how did I know to move my decimal place over to the right or to the left? Well, the simple answer is that I know that this is a positive exponent. So if I have a positive exponent, that means I have to have a number that's larger than 1. If I had moved my decimal place over the other way, then I would have ended up with a number that was smaller than 1, which is not what I want. Let's do number 14. So the first thing we're going to do is we're going to rearrange this problem here so that the mantisses are next to each other and the powers of 10 are also next to each other. So we have 4.21 times 1.3. So if we type that into our calculator, we get 5.473. Then the product rule asks us to add these exponents, so our final answer is 5.473 times 10 to the 5th power. This is in proper scientific notation, so we don't have to do anything else. Okay, for the next one, we are going to divide these two numbers first. So if I type in 9.12 divided by 3.8 into my calculator, that gives me 2.4. Then I'm going to subtract my powers of 10, and so my final answer is 2.4 times 10 to the negative 6. Again, this is in proper scientific notation, so I don't need to make any changes. Let's see if we can finish the last few problems. So for number 16, once again, we are asked to multiply. So again, I'm going to rearrange these values. So I'm going to have 6.32 times 4.1 times 10 to the 9th times 10 to the negative 7th. So if you type into your calculator 6.32 times 4.1, okay, and these are multiplication signs. I know it's confusing with the decimal signs. Those are multiplication. Okay, that gives you 25.912, and then this gives you 10 to the 2nd power. Now notice here, the problem is that this is not yet in proper scientific notation. I have to rewrite 25.912. I have to rewrite that using scientific notation. So when I do that, it becomes 2.5912 times 10 to the 1st power, and then I bring down 10 to the 2nd power. So this is my final answer, right? 1 plus 2 is 3. So my final answer is 2.5912 times 10 to the 3rd power. So let's keep going. So let's type this into our calculator. We're going to type in 2.646 divided by 4.2, and that is going to give us 0.63. Then we subtract our exponents, so we end up with 0.63 times 10 to the negative 8th. However, we have a problem. 0.63 is not in proper scientific notation, but we can rewrite it as 6.3 times 10 to the negative 1st power, and then bring down the negative 8. If you're wondering why it's negative 1 and not positive 1, it's because 0.63 is less than 1. So the only thing that remains is to use the product rule to combine our exponents, and so our final answer is 6.3 times 10 to the 9th power. And that's the end of this review.